Hello everyone, my name is Geoffrey Bossier and I am a site reliability engineer at Criteo. And today I'm going to speak about three perspectives on measuring latency. So this talk will take a practical approach. It will be focusing on measuring latency for monitoring purpose. I will also speak about service level indicators, SLE, and objectives, SLO. They are described in the site reliability engineering book made by Google, but basically they are indicators and objectives about the quality of the service that is provided. You can also check out how to measure latency by Heinrich Hartmann, which was a talk from a previous session of P99, and it's complementary to this talk. All right, so I will start with a practical example. An example I will take Criteo. So I work at Criteo, and what we do is that we are an ad tech. So basically we display ads, and to get the right to display ads, we need to win auctions. And the highest bidder gets to display the ad. And we participate in around 10 million auctions per second. And the challenges of this is that we need a lot of data to bid the right price. So for example, this data can be the current campaigns that are running, the product catalogs, or user data. And we need to take the decision quickly, in another millisecond, 99% of the time. To do that, we created the key value store infrastructure. So first, what's a key value store? So a key value store is a simple kind of database. It allows you to retrieve a value with a key. Typically, it will trade features like scan relational data for scalability and performance. And commonly, it's used for cache or as a backend for more complex databases. At Criteo, we run more than 200 clusters spread in 7 data centers. We serve 250 million queries per second, and we serve them under a millisecond 99% of the time. We serve around 1 trillion records, and everything is powered by memcached and Aerospike, which are running on 3,500 servers, running on-premise Kubernetes. So what are the challenges, what are the associated challenges with this infrastructure? So it's on the critical path of every request, and second, it's used by many teams and many applications. Because it's so central, it's very important. Also, we use many servers. I will start from the beginning. It's on the critical path of every request, and it's used by many teams and many applications. And because it's used by so many servers, so on the client side, on the server side, incidents are frequent, so being hardware failures, network issues, or performance regressions. We need a very robust monitoring system. So the goals of this monitoring system is to be alerted when there is an issue on our service. We want to avoid false positives. We don't want to be waken up in the middle of the night just because an issue on the client side that we don't control or something like this. And we also want our monitoring system to help us troubleshoot root causes quickly and efficiently, be it on the server, on the client, on the server, or something in between. And we want to expose SLIs that our users can trust so that they can help themselves resolve the issues. So if they have latency and our SLI, so service level indicators are good, they can focus their effort on trying to find what on the client is wrong. And to achieve this, we need high quality latency measurements. So where to measure latency? Here, it's a simple view of the key value store infrastructure. So you have clients. Here, it's many different instances of a product, and key value store clusters. And the key value cluster is typically consumed by different clients, and the client is using different clusters. The most obvious and simple way is to do server-side monitoring. Here I'm taking Prometheus as an example, but it can be any other source of metrics or any source of observability that you can use on the server side. Here again a simple view of a client interacting with the server. And here what you will want to measure, it's the time between receiving the client request and sending our answer. But also the server, it will, if it's because it's a database, typically it will interact with the storage. Maybe a disk, maybe a network storage, whatever, but it's important also to measure it. Also because we are on a database, we will interact, it's a cluster, so it will interact with other servers in the cluster. So we are also interested to measure the latency there. And each server, they interact with the storage. So basically, you end up with many different measurements of latency. Also, I'm taking the example of a database, but it can be any kind of service that you are giving. So again, here it's an example of a microservice or just service speaking to each other. So there are a client interacting with your service A, and the service A using service B and using also service C. Yeah. So you will want to measure the latency with your clients and with also with your dependencies. All right, so let's sum up server-side monitoring. So server-side monitoring is paramount to understand the behavior of the system, especially if you have a distributed system. It's very important to understand what is slow and understand the performance. Service time, so typically with your client, it should be measured as close as possible from the client. And by that, I mean as early as possible. You should start measuring as early as possible and to stop measuring as late as possible. So you get a more accurate representation. And troubleshooting performance is here knowing the latency of your dependency. So maybe the latency with the storage, latency with the servers, or whatever input or output your service has. Also, metrics needs to be high precision. Average is not enough. Typically, you will need percentile 99. And it's true if you care about your tail latencies, you need to measure a P99, so use histograms. So the downside of server-side monitoring is that it doesn't take into account what is between the user and the server. I will come back to it just after. Also, typically, if you are operating a database, you didn't write the software yourself. So in this case, you will have the metrics that are given basically by the software itself. For example, memcached, it's not you don't have a P99 out of the box. Also, your measurement can be impacted directly by user workloads. And in this case, if your user they start to make heavier queries but less of them, maybe you will identify it as a regression of your service, but maybe it's just more efficient to do it this way. All of this make it hard to depend on it for SLE, SLO, and also alerting. So let's go back to the simplified view of a client and a server communicating. Typically, you will have a client interacting with a server, but it's not that simple. You will have things in between. First, the server is running on a physical server. So a server in this case is software, it will run on a physical server. And the client will first interact with the hardware, maybe a virtualization layer, maybe the kernel, and also the network. Maybe it can be the network of the data center you're running, it can be internet, and it can be also the network stack of the kernel. But everywhere in this, there is a potential for added latency, for added queuing time in the system. You can also have load balancers, API gateways in the way, and you can have many, many different things. Even on the client, you also have hardware and virtualization that can add latency. So what you can do to see the end-to-end latency of your service is to do client-side monitoring. In this case, you will extract metrics and observation from your client and put them in your system. So the advantages of client-side monitoring is that it provides an end-to-end view of the service. You get the actual response time, you get actually what your client is experiencing at this moment. The downside is that it might require standardized clients. If you have many clients and they are using different languages, it might be hard to have a standardized way to consume the metrics if you are using metrics. but it might not be easy. Also, precision tend to require a lot of metrics. For example, if you're using Prometheus histograms, you will need they amplify the number of metrics by 10 or 20 compared to averages. So if you have thousands of clients, it can create a lot of metrics. And finally, but very important, it can also be impacted by other factors, by other parts of the application, because the application is not only measuring the latency of your service, it's also doing a lot of work on its side. What we see often is that an API, an application that is starved for CPU, it will start to report very high latencies on its dependency, and it can be hard to figure out what is the real cause of latency. And the same for GC poses. If you are measuring when there is a garbage collector pose, then it will have a big outlier in terms of latency. So, if server-side monitoring is too limited and client-side monitoring is too noisy and out of our control, what can you do? How can we improve? And one of the ways is to create a fake client that is stable and not noisy. And here we can see it. And often, basically, it's a type of black box monitoring where you basically have a probe, which is a fake client, that is emulating the behavior of your normal clients, and that is targeting your normal clusters. So the goal when you are building such a probe or such a monitoring system is to simulate the behavior of your client as closely as possible. And this is one of the most important things. Then you will want to have it repeatable and stable over time. This way you can compare the measurements over long periods of time, months, maybe even years. And also you want it to be highly isolated to avoid what I was speaking earlier with the CPU starve. So it's really important to avoid interferences, and to be as precise as possible in the measurements. So how do we implement such a probe? First, you will want to select a number of operations. Again, they should reflect the behavior of your users. And typically, especially for databases, you will want to do the CRUD thing. You want to replicate the CRUD. So basically, you will want to write, read, and delete from your database. But again, it's just an example, and if you are a service, it's also totally usable for that. So this operation, you will want to schedule them at repeated interval for every cluster that you have. And so if you want to measure %99 every minute, you need to measure 100 times per minute. So you need to do 100 operations per minute. Also, you will want to add a lot of observability. In this case, high resolution histograms, logs, tracing, whatever observability tools that you have. And here, typically it's okay because you have only a handful of probes, maybe one or two. So you can really go at it and add as much as you want to be as precise as possible. And lastly, you will want to optimize for latency. Typically, for your client, you will want high throughput or limit the CPU usage, but here it's okay to waste a bit of CPU if we make sure that the measurement is as precise as possible. You can also, you don't have to do only latency monitoring. You can also measure many different things. For example, the most obvious one is availability, which can directly be derived from the latency operations. So, for example, if you are doing a read and it fails, or if it succeeds, this ratio can be used as your availability. But you can also do, for example, durability to check if you didn't lose any data. For example, you can write 10,000 records in your database and check regularly if they are all there. If you miss one, it means that you lost data and it's bad. You can also measure data across data center applications, for example, the latency of the application, if the replication works at all. And you can do that automatically and very often do these checks. And it's not limited to this, you can do whatever you want. And the resulting metrics can be used as service level indicators. And typically in my team, which is where we're responsible for NoSQL databases, we don't go to production without a probe for each services. In practice, We use black box monitoring on many different technologies. So it's mostly databases, but again, it's not limited to databases, but also any services. So we use it on the key value store, and it's really the backbone for it. Memcache and Aerospike. We use it on Kafka, on the metric stacks, on the logs, and other databases that we have, like Ceph, CLDB, and Elasticsearch. Recently, we open sourced the Blackbox prober, which is a framework to build probes in Go, and it also has the implementation of several of them that we use. You don't have to use it, you can create your own, but it can give you an example of how it's supposed to work. So the summary of the black box monitoring. The advantages that it has is that it gives you an end-to-end view of the service. It's very reliable over time because you typically don't change the type of operations that you make. It's precise because you don't have any interferences. And it's easy to create. You can just take your favorite language, the one, for example, if you are doing operations with Python, you can use Python. And it's very simple to make. But the downside, and it's a very important one, is that it's artificial. You are not actually measuring the client operation, but you are measuring an imitation of them. So it's something to keep in mind. In conclusion, each approaches have trade-offs. Server side, it's precise, but it lacks the big picture. It lacks the end-to-end view. The client side, you will get the end-to-end view, but it tends to be very noisy, and it can be hard to use it, especially if you want to do alerting. And black box monitoring, it's end-to-end, it's reliable and typically precise, but it's synthetic. So it means that if you are not exactly doing what your clients are doing, a sample of what your clients are doing, then you might have your client might have issues that you don't have. For example, it can be different configuration. And it's very important to measure everything because you want to use everything that you can to understand the performance of your system. Also, none of the approach is the correct one. Typically, you want to use all of them. And to give another example of how they can work together, if the client-side monitoring is reporting an issue, but the black box monitoring on the server side is not, then it's probably an indication that something is wrong on the client side. If you have an issue that is reported by the client side on the black box monitoring, but not on the server side, it's probably something in between the client and the server, or maybe it's the server, but something that is not measured well. So this way, it's easy to pinpoint areas where to focus the investigation to find the results. So that's it for today. Criteo is hiring. We have R&D in Ann Arbor in the US and Paris in France. If you have questions, you can contact me on my email address, or you can ping me on Twitter or LinkedIn, whatever you can to find me. Thank you.